Assalamualaikum everyone. Today we will see frequency analysis of common gate amplifier. As you can see, we have already constructed this circuit, and now I am going to explain all the connections and components in this circuit. So let's get started. Here as a MOSFET we have selected IRF Z44 model, and there are three terminal. This is source, this is drain, and this is gate terminal. So at source terminal we can see there are a 100 microfarad capacitor. Along with these two nodes will act as input voltage. We will put our signal generator here, and there are this capacitor in parallel with this, which will act as a source resistance. Now at gate terminal there are a 100 microfarad capacitor along with this resistance. The value of this resistance is selected using DC biasing. Then we have connected this jumper wire from drain to this point, and we have connected these two resistance here. Then we have also connected this jumper wire, which will act as a DC biasing node. Along with we have here this 47 microfarad capacitor, which will act as a bypass capacitor, and also we connected this high resistance that will use as an output resistance. We will measure output voltage here. So that's all, and now we will see frequency analysis of this input and output voltage.
We will show the frequency response of the common gate amplifier circuit. So we will take different frequencies and we will show the output. So here first we take the frequency at 10 Hz. So we will now show the output of the curve. Here the input signal shows that peak to peak is 464 megavolt, and now we will show channel 2 here. The output signal shows that peak to peak is 2.84 volt. Now we will take a frequency at 50 Hz. So if we take the frequency at 50 Hz, then our output will be shown in the oscilloscope here. So if we see the output here, channel 1 shows that here channel 1 shows 260 millivolt peak to peak, and channel 2 shows that peak to peak is 5.92 volt. So now we will take frequency at 100 Hz. So if we take 100 Hz frequency, now we will show the output in the oscilloscope here. So here channel 1 shows that frequency is peak to peak 176 millivolt, and now we will show channel 2. So channel 2 shows 6.7 volt. So now we see that here the graph is sloping upward for the frequencies 10 to 100 volt. Here now we will take frequency at 1 kilohertz. So now we will see the output here. So channel 1 shows here that the peak to peak voltage is 130 millivolt, and now channel 2 shows here peak to peak voltage is 6.9 volt. So now we will take here frequency at 5 kilohertz. So now if we take frequency at 5 kilohertz, then our oscilloscope shows that here channel 1 shows a peak to peak voltage 126 millivolt, and channel 2 shows 6.8 volt. So if we see here between 1 kilohertz and 5 kilohertz, the slope is almost parallel to x-axis, or the slope is almost zero here. Now if we take the frequency at 1 megahertz in the function generator, then we will see the output in the oscilloscope. So channel 1 here shows that our peak to peak voltage is 144 millivolt, and channel 2 shows here peak to peak voltage is 3.2 volt. Now if we take frequency at 2 megahertz, then our oscilloscope shows here that output is in channel 1. In channel 1 the peak to peak voltage is 140 millivolt, and in channel 2 the peak to peak voltage is 1.72 volt. Now if we take 5 megahertz at our function generator, then our oscilloscope shows that here in channel 1 we show the peak to peak voltage is 166 millivolt, and if we show the channel 2, our peak to peak voltage is 640 millivolt. So here we see that our output value is gradually decreasing and the slope of the curve is also gradually decreasing here. Sum up here, at the early stage at low frequency, actually the graph here will increase drastically. At the middle stage, at the mid frequency stage, here the graph will remain almost constant, almost flat here. And at the last stage, at the final stage, when the frequency is at the topmost level, at 5 megahertz or 1 megahertz, here actually the gain almost decreases to zero, and the slope of the graph almost decreases here gradually and drastically here.
So if we simplify the CG amplifier circuit, it looks like this. And if we plot the gain versus frequency plot, then it shows like this. So why does it look like a bandpass filter? Basically, at low frequencies, the coupling capacitors have high reactance and it blocks a part of input signal, which reduces the gain. In the mid-frequency range, the capacitors act like a short circuit and all the current goes through the load resistance. That's why the amplifier provides a constant and maximum gain. So in this region, we get almost constant gain. And at higher frequencies, the internal transistor capacitances of the MOSFET, like CGS and CGD, they start affecting the circuit, which also reduces the gain. That's why we get lower gain at low and high frequencies and high and constant gain at mid frequency range.